All right. Welcome. Awesome. Welcome to perhaps the best mini lecture you guys will see this entire year. I know I say that every single time. But guys, this is going to be amazing. So, before I get started, I just want to do a real quick announcement. So, we've been telling you guys on and on and on, just raving about how good IntelliJ is, how good PHP Storm is, and how good WebStorm is. And so one of your fellow launch coders actually went out there and took the initiative. He contacted JetBrains and said, hey, we've got a bunch of people who want to use your product. What can you do to help us out? And they actually gave us a significant discount on the product. So Josh, come up here real quick. Come up here.
All right. You said come up here? Come on down.
So yeah, guys, you have Josh to thank for saving you $70 each on this product because you guys are going to be able to get this for $30. It normally costs $100. Josh just saved you $70. So buy him like a drink or something like that. All right, so essentially you just go to that link, and we'll post that link up on Reddit. And actually, if you want to copy it down right now, go ahead. If you guys aren't big Reddit users, go ahead and copy down that link, fill out the application, make a PDF of the welcome email from CS50 when you register. So yeah, Josh. Thank you. Josh has also been taking care of videoing all of our mini lectures. He does a really great job. He edits out all of the parts where I mess up, so it's actually more pleasant. More pleasant to watch them online than in person, perhaps. So big thank you for Josh.
Hey, Mike.
Thanks. Yeah.
With this $29 price, is that just a year, or is that for as long as you want to run the product and there's a yearly maintenance fee or something?
Okay, so yeah, that's as long as you want to run the product. Now, if you want to upgrade in the future, they'll charge you like $20 or something. But
I'm sorry, I didn't catch. Is it a purely academic license?
Yes, it is the academic license.
Okay, so it's academic, but you know, okay, so remember what that means. You can't use it for profit.
Yeah. But you guys don't have too much to worry about that. They're not going to come hunt you down or anything. And so you guys, PHP Storm's been out there for a long time, so I know they keep making it better and better. But this thing is really, really stable, so you can use this thing forever. And it will be great. You can pay $20 like next year or 2 years from now and get the update. And so it's only $20 for the update. It's $99 to buy it up front. So once you pay that upfront cost, then it's really cheap to stay in the program. So yeah, that's awesome. Awesome. Okay, so today we are talking about the most widely asked interview question since the beginning of software development. Does anyone know what this interview question is? I'll take any guess.
Do you know Java?
You know Java? Okay. Fizzbuzz. I don't even know what those are. Fizzbuzz.
Yeah.
Nice.
No, object-oriented programming.
Getting close. Same way.
Let me see what you created.
Yes, that's exactly. Actually, most interviews, they don't ask you what you've created. You guys have a special case where you can actually show off what you've done. So, the most asked interview question since the beginning of programming is, what are the 3 principles of object-oriented design? What makes object-oriented design different from procedural programming? I've mentioned it to a couple of you. Is Adam here? No. Okay, so there's a simple acronym to remember this, and you can remember it by PI. It's easy as pie. P-I-E. Yeah, you guys have heard of that. So the first word is actually really scary. It's not that bad. In fact, I'm going to work from E-I-P. I'm going to work backwards. I'm not even going to tell you guys what the first word is, just because it looks so mean and so complicated. I'll tell you that the E is encapsulation. I'll tell you that the I is inheritance. And the P The P really won't be that bad, but I'm not going to tell you what the word is right now. So, let's go ahead and walk through just some real basic examples and talk about why these are the principles of object-oriented design. So, encapsulation says that you protect the inside of your class. You know, unlike, ooh, good call, thank you. I actually looked up how to do this before I came, so.
Is that a browser?
No, this is IntelliJ IDEA. This is free and open source, so if you want to do Java, just download IntelliJ. It's completely free, it gives Android support, full Java support. It's fantastic. From the same people who do JetBrains. And so is that big enough? Or can I make it just a little bit smaller?
That's fine. That's perfect.
Okay, great. So you guys know in C that you have structs, right? And you know, on your struct, you can put ints, you can put strings, you can put whatever you like on that struct. But that struct is visible to everything within your program. Anybody who wants to access that struct can access it. And we know with object-oriented programming, objects are pretty much structs, but we can add methods onto them. And so last time we talked about this, I lied to you a little bit in the fact that not only can you add methods to objects, but you can also make things private in objects. You can say, I don't want anyone else seeing this. So you guys know whenever you've got a variable in C and it's not in scope, like let's say you declare a variable inside of an if statement, and that variable is not visible outside of that if statement. You guys know about scope. Using private on objects allows us to say this variable is not in scope for anybody else. And it has some really, really awesome design implications. So let's take a look at what bad encapsulation looks like and how it can really get us into some trouble. So we've got a simple rectangle class, and as you can see here, it's really, really easy. We've got an int with width, an int with height, basic constructor. We've got a nice method on there that computes size. That's great. So we don't have to set size anytime width or height changes, even though I can't change in this spot because this is a mutable object because we're not in setters. Actually, it is mutable because we've got public. Never mind. So we've got this perimeter, but notice we've got public on int and height. And so what that allows everybody to do, anybody who wants to use this application, we can go ahead and say, hey, we've got a super sale on TVs. TVs by the width and height. So if I run this real quick, just right click, hit run. Okay, we say we've got a super sale on TVs 10 by 15. Size is 150, perimeter is 50. Guys, this is back before the days of flat screens. Remember, you know, the square TVs? Those are great, right? So this class was all good and dandy back in the day. In fact, we can make this class just a little bit better by, you know, applying correct object-oriented principles to this. So if we want to look at what good encapsulation does, is we can say, okay, instead of making these two, let me make that bigger. Instead of making these two attributes right here public so anybody can access them, we're going to make them private. We don't want anybody to know what's going on inside of this object. Can you see it?
Yeah, I can see it. But my question was, it's private struct with public members? What's the purpose of that?
Oh, a private struct with public methods?
Or members?
Oh, with public members. Oh, like having these methods.
Like that very first line up there.
Oh, like this one?
Yeah, private static class.
Oh, okay. No, good
Okay,
question.
it's not a struct class, but why? Oh, I see what you're saying. Okay, so the entire class becomes private, but the members can be public.
Yeah, and actually, I'm glad you brought that up. I just did this for the sake of a presentation to keep everything in the same file. You know, typically this rectangle would be in a file all its own. It would be public class rectangle. And we would, in fact, I can refactor that here real quick if you would like to see that. Let's see, extract class.
You just hit something I've always wondered about. Why we use public, why we use private, what's the difference?
Yeah, it's just controlling the scope. And so in this case, I just did this out of habit to say it's a private class, but I can make this It's a public nested class. Normally I would have another class out here called Rectangle, and I can make that up real quick. Make a new Java class. I want to say it's a rectangle. Yes, I want to add it to Git. Thank you very much. So this class would normally be looking just like this. And so it would be a public class, everything. Normally you make your classes public because you want other people to be able to use them. So you're gonna package this code up and you're gonna put it out in your company, and then people can import this code as a library. So you guys know how you have like some of the helper classes that you get in some of your C programs, like on find. They gave you that generate method. That's a shared method. So essentially, we can just pull this class into another person's project after we package it up, and they can use the same code that we're working on. Yeah.
So public is not default, or you just doing that to be clear?
Oh my gosh, good question. Okay, so if you really want to get technical about it, good. No, that's great. We can actually say the default for Java is not to put public on here at all. And so by saying this, you actually define a different scope for this class in which you say, this class is only visible to other classes within my package. So that means if you've got an application that you're running and you're using my code as a library, you probably wouldn't be able to use this class because your classes aren't in the same package. Only classes in com.launchcode will be able to use this rectangle class. And so by saying public, I say anybody can use this class. And then by saying private, actually, I'm saying nobody can use this class. But it doesn't even let you make a private class because that wouldn't make sense. No one's using it. Now the reason I can say public class, private class right here is because it's a nested class, and since it's a nested class, it's automatically in scope. And so there's a few rules to Java scope, and don't let them drag you down. You'll get used to them pretty easily. So, but yeah.
So, can you define package and kind of give us an idea of how they're used?
Yes, great, good question. So you'll notice right here that a lot of Java classes, they begin with like com.launchcode or com.mycomany, and essentially that provides a unique identifier for every single class. That way, if you start using your code in someone else's project and they have a rectangle class as well, most likely they won't have the same prefix as ours. So what you want to do is you want to create a unique prefix. And then you can also use packages to organize your files. And so I would say, I might say examples right here and create a new package called examples. At the top of every class, it has a package. It defines what package it is currently in. And so, it's just a unique way for you to identify one of your classes. So that way, if somebody's got a class with the same name, you can tell them apart once you start running the program. No, guys, these are good questions. These are very good questions. So anybody else? Okay, so we'll go back to looking at the public and private. Now, thank you for bringing up about the classes. Pretty much ignore the public and private on the classes right now. We're just going to look at the public and private of the attributes and of the methods, essentially. So by saying private int width, we can say that no one is able to access this width attribute right here. In fact, the only way to access this width attribute is by calling this method, this getter. And so we can provide this method called getWidth, and this is public. Everybody can get to it. And if you want to get the width, you call this method. And if you want to get the height, you call this method. So now up here, when I run it, I say my shape.getWidth, my shape.getHeight, instead of just calling the basic attribute name. And so you guys, it might not seem that significant at the moment, but getters and then sometimes setters, they're a pretty significant part of Java in the fact that it protects our code from having to know too many details, from being too tightly coupled. So imagine, it took me a lot of thinking to think of a situation in which rectangle could go wrong. I finally came up with a very derived case. So if you entertain my fancy here, then we can actually make this break. So what if, we're in the TV business, and TVs used to be square. And, you can write this awesome rectangle class, and everybody in the company is using it. I mean, like, you're getting high fives when you walk down the hall. I mean, you're like a rock star because you wrote this class. Everybody can use it. Everybody loves it. And so, let's say in the case that you wrote this first class, this poor encapsulation class, what if your boss came up to you and said, hey, you know what, TVs are changing these days, actually, and we need to optimize this. We need it to be more closely fit to our domain. In fact, they measure TVs nowadays by diagonals instead of by width and height. And so instead of saving width and height, we just want to save a diagonal. It will save us 32 bits on each object. It's an optimization. We need to save our rectangles by diagonal. And we're just going to assume that they're 4:3 ratio. So if we did bad encapsulation, that really puts us in a bind, right? Because all those people that were giving us high fives down in the hallway, they're going to be pretty pissed off at us now, right? Because their code that they wrote using our code, their code is calling myshape.width. And once you get rid of myshape.width and make it public int diagonal, oh man, all their code's broken. Like, you just ruined all their code. Everybody has to go back and change because of you. It's a bad situation. It's not a situation you want to be in, right? But by using proper encapsulation, you can say, well, you really shouldn't access that width and height because that's an implementation detail. That's inside of our object. You should access get width and get height. Now that allows us to change how width and height is computed in the future. So let's take a look at how we might do this with encapsulation saves today, right? So here we're calling get width and get height still. These methods are still around. People still love you. You still have an awesome class. But you were able to modify your class to the new TVs by using a diagonal. And instead of just returning width and height, we can actually compute that width and that height based on the diagonal because we know they're of a ratio of 4:3 TVs. And so even though and we're just rounding right now, just for being even sake. But you still have that same contract. You're not breaking anyone else's code. And so, yeah, guys, always, always, always have private access, private attributes, public getters and setters. That's the story of how encapsulation can save the day. Nice, right? Oh, yeah. Who knows what a getter and setter is? He can just wrap this up. Sam.
Basically, getter is you simply, just like in that get width, it just returns the value of interest, and then a setter is it sets the value to what you want. So if you did a public int set width, or actually it would be set diagonal in this case, you would write code that would set that diagonal to a certain number. It's a way of changing the data behind the encapsulation.
Exactly. And so even though this isn't built in as a language structure in Java, this is pretty heavily ingrained in Java. In fact, that this IDE even has a way to generate getters and setters. So if I say generate all my getters and setters, I say diagonal, boom. It just goes ahead and makes the methods for me because it knows those are supposed to be there. So that is that. That is how encapsulation can save the day. Use it, love it, it is awesome. So who remembers what the second principle of object-oriented programming is? Inheritance. Nice, right?
I want an inheritance.
So, what inheritance allows you to do is it allows you to share code. Did you guys ever feel like in your C programs they were getting a little bit wet? Like, maybe not dry?
My code's always wet.
Yeah, you guys don't want wet code. You want dry code. Do not repeat yourself. And inheritance is one of the clutch features that allow you to never repeat yourself. Essentially, you can say, well, you know what? This class has this method, and this other class needs this method as well. I'm going to go ahead and share that method between these two classes. That way I don't have to write it twice. And so if we think about it in terms of phones, you know, we've got a normal phone, and it can call people. And in fact, I've got a normal, I just so happen to have like a phone class right here. Wow. Yeah, so, you know, it comes up and it says, hey, I'm a phone, whenever it gets made, and then it's got one method on it, and it can call somebody. It says, dialing 1-800-Dominoes. That's all a phone can do. But, you know, you also have cell phones. And, you know, cell phones can call people as well. But, you know, cell phones also have the added benefit that you can send text messages. And so it wouldn't be appropriate for the phone to have a send text message method on there because phones can't do that. However, it would be appropriate for cell phones to have that, and we would not want to repeat the dial method because then our code would become duplicated. So what we can do is we can say extends. This cell phone extends phone. Take a look at just this highlighted section. So this highlighted section says, all right, it says, hey, I'm a phone, and then I'm dialing Dominoes. And now, where does this hey, I'm a phone text come from? Does anybody know? Sam?
Comes from the constructor method.
Yes. So in order to make an object, you have to call its constructor. And that's just the object that you call set it up. So if we say control click, we can actually go right into this just by clicking on the name. Pressing control and clicking on the name, we can actually go right into this class and we can see, hey, you know, if I want to create a new phone, I just say new phone like this. And whenever it gets created, it's going to say, hey, I'm a phone. Very simple, right? But take a look at the cell phone. Let me make this a little bit bigger. It says, hey, I'm a phone, and I'm a cell phone, and then I'm going to dial, and then I'm going to send this text message. And it's like, wait a second. Something funny is happening here, right? Right? Because if we say control click on cell phone and it takes us to that class, this only says, and I'm a cell phone. It doesn't say that I'm a phone as well. And so the lesson to learn from this is that this constructor is actually going to call its parent constructor. In fact, Java does this implicitly. It calls new phone at the beginning of the class, at the beginning of the constructor. And so you can start to see that hierarchy. You know, in order to make a cell phone, first you have to make a phone, and then you're going to make a cell phone. And then now this object has both the dialing method and the send text message method on there as well. Right? Pretty nice, huh? Pretty nice. You guys feel comfortable with that? Yeah? Okay, good. We're going to comment this out. Next, all right, so the last one is, I'm going to finally tell you the scary word, the P in pi. So you have encapsulation, inheritance, and working backwards, the P is polymorphism. Oh my God! What the hell is polymorphism? Like, the first time somebody asked me that in an interview, I was just like, yeah, it can be polymorphic inheritance as well.
Well, I mean, inheritance is polymorphic. I'm just trying to understand how it's pronounced. So it's pronounced polymorphism, and you can actually do it two ways. You can do it through inheritance, and you can do it through interfaces as well. And so polymorphism essentially means that this object can take more than one shape. Poly and morph, change shape. So that's the layman's terms. But to think about this in code terms, that means, so we know that every object has its own class, right? Because we can say, hey, this phone This phone object has its class of phone, right? Polymorphism allows us to have an object with multiple classes. Kind of crazy, right?
So an object can belong in two different classes?
Yeah, an object can be two different things.
Well, no, but I mean, one object that's the same thing could belong to two different classes, is what you're saying to me?
An object can belong to two different types.
But not two different classes.
Yeah, I think, maybe one thing you might be asking is, like, it can only inherit from one class. I forgot to mention that.
Okay.
It can only inherit from one class. And so, I'm going to talk about that in a second. That's why we need to use interfaces, because sometimes we can get in kind of a bind. I've got a really cool example I'll show you guys for that.
Well, more better way to describe my question was, if I had users, right, that use cars, and users that use bikes, could I have a user that used bikes and cars?
Yeah, exactly. Dude, you're thinking right along the same lines.
Okay.
Because, yeah, you have to say this,
So I don't have to have bikes user, I don't have to have cars user, I can have user.
user uses some type of transportation. And that transportation might be a car, it might be a bike. But that's how you're right on the money. That's how you can say, this car is also transportation, this bike is also transportation. So instead of saying, hey, this person wants to ride a car, we can say he just wants to ride transportation. And now we can use both bikes or cars.
But we only have to use the user once.
Yeah, we only have to use the user once, I think.
Otherwise,
Okay. Okay, so to talk about how this can be used in two different ways, the first way, you guys already know how this can be used. We just talked about inheritance. We talked about how this cell phone, before it actually gets made down here in the constructor, actually the phone's constructor gets called first, then the cell phone's constructor gets called. And so it's actually creating a phone and a cell phone. This object can be both of those classes, since cell phone inherits from phone. And so if we take a look here, we make a new cell phone, and normally when we would declare a new cell phone, we would actually just say cell phone right here, right? But instead, we said, I want the cell phone just to be a phone right now. And the Java type system knows. So let me comment this out, and let me comment this out. So this cell phone object, inside the cell phone object is a cell phone. It's only appearing as a phone right now to the Java type system. And now in dynamically typed languages, you could probably get away with something like this. Something like JavaScript. JavaScript just checks to see if that object has that method. That's all it does. But the Java type system is strongly typed. And the Java type system only knows what you tell it. So, even though this cell phone object is both a phone and a cell phone, whenever you come down here and you say, hey, I want this cell phone to send a text message, Java type system says, what? I don't know what you're talking about. This thing's a phone. It doesn't realize, because it's strongly typed, it doesn't realize that there's a cell phone inside. Now I can prove it to you. I can say, hey, I want to cast this back into a cell phone, and I'm going to call this cell phone 1. And now it's like, oh, you're calling that a cell phone? Yeah, you can send text messages with that. That's not a big deal. Right? Yeah. Okay, so that's how you do polymorphism through inheritance. This cell phone can be a phone or it can be a cell phone. But now, as we mentioned earlier, you can only have one parent in Java. You can only inherit from one class. There's no multi-inheritance. So that means, what if you've got a situation? We know computers are phones are becoming a lot like computers nowadays. And so, what if you run into a situation like this? All right, I've got a computer, and it sends an email. And I've got a smartphone, and it sends an email as well. Now, I can't Now we could say a smartphone is a computer. Let's stay away from that argument right now. Let's keep my example simple. Now we can't say that a smartphone is a computer because a computer is something that sits on our desk. It has a keyboard, it has a mouse, it has a monitor. A smartphone is something in our pocket. So we really can't do an inheritance because smartphone is already inheriting from phone. It can't inherit from both smartphone and computer. And yeah, don't even get me started on tablets. And so in this case, what we can do is we can bring the two of them together by using an interface. Now, interfaces, they're not something you've seen in C before, but they allow you to infinitely extend your code. Infinite possibilities. Let me show you how. So, I've got this computer. I say control-click. It takes me to this computer class. Great, and it's got this method called send email. But also notice it implements this thing called email ready device. Well, what's email ready device? Control click. Oh, you know what? It's an interface. An interface is just a listing of methods, and it says, hey, in order for you to be an email ready device, you have to send email. That's what this says. You have to have all of these methods in order to be this type. And so, if I take, I can take implements email ready device off. And, I can still have the send email method on there, but, it's going to confuse the Java type system. If we were in JavaScript, it would be like, okay, you've got a method on there called send email. I'll just use that. It's not a big deal. Java, no, it needs to know that this send email method is exactly the same as the other send email method. They're of the same type. And so, if we say, right here, I'm going to test out email. I'm going to send an email with both my smartphone, and I'm going to send an email with my computer. Just highlight this, press Control/, and comment it. And now it's saying, hey, dude, this computer, this is not an email ready device, all right? This is just a computer. I don't know what you're talking about. This thing cannot send email. And so what I can do is I can just add this implements back on and say, hey, you know what, I do want this to be an email ready device. And since it implements email ready device and it has send email on it, it's going to be like, okay, yeah, we can call this an email ready device now. Now what happens if I don't have the send email method implemented? It's going to be like, whoa, wait a second. If you want to be an email ready device, you have to have this method. Otherwise, I'm not going to compile. Otherwise, I'm just not going to compile. So, in IntelliJ land, the shortcuts fix this. Shortcuts fix anything in IntelliJ. It's just pressing Alt-Enter. It's going to tell you what to do, and then it's going to do it for you. So, I don't know what this error means. I'm just going to press Alt-Enter. Oh, I'm supposed to implement the methods? Nice. Hit Enter. Okay. It just created the method for me. And now it's happy. So I'm going to put that back right there. And let's go ahead. I'll run it for you guys just to show that it really works. Okay. I don't have anything else. Okay, we say, hey, I'm a computer. I'm sending an email. And then we say, hey, I'm a phone, I'm a cell phone, and I'm a smartphone, because smartphone extends cell phone. And now I'm going to send an email from each device, and we can say, okay, so whenever you send an email from your computer, it's just a normal email, right? But whenever you send it from your smartphone, it says, hey, this email was sent from my iPhone. That's, and that kind of brings me to my next point, is that, we can use this, even though our methods, even though we want this object to do different things, just like a bus and a bike and car, you're going to get there in different ways. But you just want to tell this guy to take some type of transportation, you can implement the methods in different ways. So, whenever we tell a smartphone to send an email, It's going to say, hey, this was sent from my iPhone. And that's okay, because it has a different implementation than your computer. It just says, the computer just says, hey, I'm sending this to you now. So, to really wrap it all together, like oh my God, I think this is pretty awesome at least. This allows us to infinitely extend our code. Infinitely extend our code. So, let me show you an example. I'm going to comment this out. I'm going to comment this out by pressing Control/. That's all commented out. And I'm going to open up this. Now, I'm going to take all of my phones that I've made so far. Let me open these phones back up. I've got a cell phone, I've got a smartphone, I've got a normal phone. Great. I'm going to take all of my phones. I'm going to dial Domino's first. And then I'm going to say, ET phone home. Now, what do you think is on this method signature for ET phone home? Come on, you guys got this. What am I passing in?
An object?
Yeah, what type of object?
It's
Yeah, I'm just passing in the phone. So that means I say ET phone home, I pass in any phone, and I say phone.dial.
Oh, you're sending a message to it, right? Isn't that what that's called? Sending a message to between objects, or?
Oh, I'm just calling. In Objective-C, in Objective-C, you send messages between objects.
Oh, okay.
Yeah, in Java we just call objects.
Okay.
And so what that means is we don't have to just pass in one type of phone. We can pass in any type of phone we want. And in the future, if we need to make a new type of phone, we can just make a new type of phone. And as long as it looks like a phone in the Java type system, we can use it with our existing methods. So, have you guys had enough? Is that time? Okay, have you guys had enough punishment yet? Like, you want more?
I have a question.
Yeah.
All right, in using this, and I'm guessing it would be an interface. I'm not sure. Let's say I've got two different types of objects. One a computer, one a phone. Of any type of phone, any type of computer. I want to send a text message. Now I know that I can send a text message from a phone by simply sending a text message from a phone.
Yeah.
But if I have to send it via email, I have to send it a different way. So would I have an interface that was intelligent enough to figure out who was calling the interface, whether it was a phone or a computer, or how would I implement? Do you understand?
Nice, yeah. Oh, I get exactly what you're saying. That's an awesome question. In fact, you bring up something that I really wanted to mention. I wasn't sure how I was going to fit it in. Always prefer, this is going to sound abstract, always prefer composition over inheritance. In fact, you know you can use inheritance when it is like textbook example. If not, you want to use interfaces. And the way you would solve that situation is, you would have, perhaps you could have some type of text message. It would be an interface, and it would be a text message device. And you would have a phone text message device and a computer text message device. And then whenever you make your computer, you would just say, hey, since this is a computer, I'm going to give it a different type of text messenger. And since this is a phone, I'm going to give it a different type of text messenger. And then we don't have to extend use parent-child relationships. We can just say, the computer's going to have a text messenger, the phone's going to have a text messenger, and we can plug in whatever type of object that we need that would fit our situation. Yeah, please do.
Yeah, so basically, what you're saying is these things, no matter what they are, if they are a text message device, you don't care how it does it. You just care that it can. That's what the interface tells you, is that this can be a text message device. You can treat it just like a text message device. You don't care how it does it. You leave the implementation up to the computer or up to the smartphone. But you just know I can send a text message, and that's all you have to care about.
Yeah, just use, yeah, exactly like Keegan said, just use an interface and it, well said. Yeah, did that make sense? Okay.
That's what I was thinking, but I just wasn't sure.
Yeah.
Can you real quick go over just look at the syntax again real quick? I think I missed something.
Yeah, which one? Which one?
Just down a little bit. The one that had the semicolon. I think it was the interface.
Oh, I'm sorry, which one?
For phone.
Your cell phone?
Or I mean it has a colon.
Oh, for each loop.
Oh, the for each loop.
Oh yeah, for each. Alright, so that's for each.
Yeah. Oh my gosh, there are like a million ways to use loops in Java. I
I
mean,
wasn't sure what that was.
there's at least like 7 different ways to use loops in Java. For example, we could write this in the classic C notation. We would say int I equals 0, I less than phones at length, I plus plus. You can do that too.
Yeah, I got it. I just didn't realize it was a for each loop. I thought that was some.
Yeah,
That was kind of space.
that was just a little syntactic sugar that Java throws into, so you don't have to do this stuff all the time. Good question. Very good question. Nice. Yeah. Oh my! I really want to show them to them, but I don't know if they can. I've given them a pretty brutal beating today.
You did kind of lay it down.
I know. It was a world of hurt. I'm sorry, guys.
I feel totally exhausted. What do you got?
You guys want to see it? All right. This is really awesome. I mean, this is like, if you want to do Java, you have to see this next.
Bring it on.
Go piece. It's going to take like 5 minutes.
Types, man.
All right, let's do this. Let's do this. All right, great. Fantastic. I'm really excited. Okay. This encapsulates all of the principles of polymorphism, inheritance, and encapsulation.
You get the whole pie, guys.
You get the whole pie. Not just piece of pie, the whole pie.
Good joke.
All right, so actually, I came ready. This afternoon, I was thinking about, collections would be a perfect way to show some of these principles. In fact, you guys know that Java doesn't really use arrays. They're in the language, but they're not really used at all, right? They're pretty much the same as C arrays. But Java has something better. We've got an abstraction on top of the arrays. And so what I want to show you is how these collections use object-oriented principles to hide the details, the nasty, nasty, gross details of arrays, right? So, I'm going to say right-click, I'm going to say show history. It's going to take me back to, let's see, 2:40 this afternoon.
Another wonderful feature of IntelliJ.
All right, here we go. I found the piece of code that I was working on at 2:40 this afternoon. I didn't have to use Git, it just keeps track of my file changes for me. Not a big deal. Okay. Shoot, actually, I'm sorry guys, I want to go one more back. This isn't good enough. Actually, maybe it's later in the day, maybe it's like 3:24.
Do you have to commit all that to it, or is it just there?
No, it just watches the files anytime you make a change. It says, and yeah, if you want to add something back in, click this arrow. Take something out. What?
Does it do that in debugging too?
Yeah, it'll just show you the diff between files. But debugging is it's seamless. Like you actually see the line of code that you're on, and it'll actually highlight it, and you can just put your cursor over each variable, and it'll be like, hey, this is what it's equal to. Yeah, it's really nice. And it's in PHP Storm. It's all the same. Okay, let's see. Where is it? Here we go. This is exactly what I want. I'm going to right-click on it. I'm going to say revert. It's going to take me back in time to 3:24 p.m. Great. All right, so I've been telling you guys all in all about collections, how much arrays suck, and how much collections in Java are better. So you guys know that whenever you have a C array, if it gets too big, then you have to wipe out the array and make it bigger, and it's a giant pain in the ass, right? Let's take a look at this array list. Now this array list is pretty much the same thing, except it's going to initialize itself. It's going to be like, hey, I want to be about the size of 10. And inside of this array list, we've got an object array. So even though on this array list we can never get to this array, it doesn't matter because it's giving us all of the methods that we need to work with this array. For example, if we look at the interface that says what methods should be on this object, we see that we can get the size, we can get whether it's empty or not, we can get contains, an iterator, we can even convert it to an array, and we can remove objects, we can add objects, we can add all objects, we can remove all objects, we can clear it. It does all of this without ever telling us that there's an array inside. In fact, if I hadn't downloaded the source code and applied it to this project, I wouldn't, I mean, I know from past experience, but you wouldn't even know that there's an array inside it. It's just an array list, and it just works. I don't care. I lived in that ignorance bliss for many, many years. And then one time somebody in an interview was like, so can you tell me about the performance impact whenever an array list gets too big from its initial size? And I was like, oh. Well, you guys are C programmers. You guys know what happens when an array list gets too big. So whenever we say, I'm going to look for add, actually, I'm just going to go back to list, add, here we go. Where is this implemented? Oh, array list. Here we go. Nice. So each time we add something to the array list, it's going to check the size of this array. And you know, if we are bigger than the array itself, it's going to say, let's go ahead and create a new array and just hold it inside. And now we can seamlessly have a seemingly infinite collection without ever having to make it bigger. Now, once you get into real big performance things, you guys will know deep down inside there's an array, and once you get bigger than an array, you get a little performance hit whenever it has to copy it over to a new spot. But then you use linked lists. Good. I like it. That's an excellent segue. So you guys know from polymorphism that because this array list, because it implements list, I can also call this array list just a list. I don't have to call it an array list by name, right? Well, Keegan mentioned, you know, whenever you do have that really big data and you have to grow the list whenever you extend the initial size, you know, you can use a linked list right here. And so now...
Is that a type?
Yes, exactly. And so now this is a completely different class. But notice it has all the same methods as our array list because they both implement this list. But now the linked list does things a little bit differently. If we go down to the add method, I'm just going to go here, I'm going to say add, here we go. I'm going to add something to a linked list. Nice. This one, instead of expanding the entire size of the array, this one has, you know, it's got a pointer between, it has a pointer to the next one and the previous one. And so now whenever we add a new item to the list, it just says, hey, just add this one onto the end and add a pointer to this next one. We don't ever have to outgrow our array. In fact, I don't think there's even an array inside of this, is there?
No, absolutely not.
Yeah, there's not even an array inside of this object, inside of this linked list. And so you see how that can really benefit? Like, so this array list has an array. This linked list does not have an array. Because this linked list didn't tell us how we were doing things, we can switch up how this thing works without having to change it with using all the same methods. Yeah, you'll just use a little bit more memory. But it's cool, right? Because we can just swap things out. We can change how things work without changing any of our code. Awesome, right? Right? So how about, how much did you guys really enjoy writing sets? Did you have to write sets? You had to sort stuff right and key sets right?
Yeah.
God, it was a pain, wasn't it? Yeah, oh my gosh, hash sets. You know, Keegan, I'm glad you mentioned that. So, since we've got all of these abstractions on top of arrays, why don't we just make an abstraction for sets? Now, you guys know that a list is an ordered array of items. A hash set is just a unique list of items. So we can say hash set right here. Oh, not compiling. Well, you know what? I believe this list, it extends collection. If it extends collection, I wonder if hash set extends collection as well. Let me check. I think it doesn't. Oh, wait, hold on a second. Hash set extends abstract set and abstract collection. Oh my gosh, this one's a collection too. You know what? If both of these are collections, let's just go ahead and call this a collection now. Nice. So now, guys, I'm using pretty much the same API as before, the same group of methods to work on this array, but I have completely different implementations. You know, the hash set's going to give us a unique list of items. The linked list is going to give us a performance ordered list of items. The array list is just going to give us a big list. And so there are other types of hash sets that we can implement as well. And you can even implement your own. You can even implement your own data sets. But just remember, in Java, never sort an array because it can be done for you.
Way faster.
Way faster. I mean, these guys are really good who write this stuff. And I mean, I know you guys a bit too, but it's just like, they're super awesome. I mean,
You can't beat Tensor.
yeah. So in Java, you never sort anything because it's already done for you. In Java, you never have to filter. Well, you never have to make your own type of set because it's done for you. You never have to make your own linked list because it's done for you. You never have to make your own array list because it's done for you. And there's also a map. But maps are a little goofy, so they don't extend collections. So I'm not going to even talk about them. But there, you guys, I laid it down you. That was a world of hurt. We even talked about collections today. I mean, the fact that you guys stayed through this entire thing is pretty incredible because this was a lot of content. A lot of content. You guys did awesome. Oh my God.
You did awesome, Mike.
Thank
Yeah,
you.
thank you.
Thank you. All right, so you guys are free to go. If you have any questions, shout them out now or come up here afterwards. We'll be sticking around for a little bit tonight, and then I might have to take off a little bit early. But thank you guys. Hey, Wednesday. I know I said this tonight, but Wednesday is going to be a truly, truly awesome talk. I mean, you guys are doing JavaScript right now. You said 8, right? Yeah. Okay, that's fine. But you guys like things that look good, right?
Yeah.
And you guys would like to learn how to use Twitter Bootstrap, right?
Yes.
Nice. And you guys might even like to use jQuery to do like AJAX calls. So it doesn't look like the website's from 1999. That's what we're going to tell you Wednesday. It's going to be awesome. We're going to have breakout sessions on how to do web programming after that. And maybe ASP.NET. Oh my God, Keegan, that looks awesome, man. Keegan posted the calendar on launchcode.us. So go check it out. It's going to tell you everything that's coming up. You guys still have a lot out there to learn. So, yeah, looking forward to it. Yeah.